This is Balvikan Bharti and your mentor Abhilash Sarkar. We have reached problem number 39 in time, speed and distance. Now we will move on to the problem number 40. This problem number 40 says Amar, Akbar and Anthony decide to have a X meter race. Anthony completes the race in 14 meter ahead of Amar. Akbar finishes 20 meter ahead of Anthony and 32 meter ahead of Amar. What is Amar's speed? Okay, so now let's say they are having X meter race, so all has to cover a fixed distance of X. Let's say this is the position and the distance is your X from here to here. Now the first case where it is said that X meter race, Anthony completes the race in 14 meter ahead of Aman. Means when we compare Anthony and Aman, Anthony has reached this destination. Let's say this is A, this is B point, and Anthony has reached there where Aman is 14 meter behind. Why? Because Anthony completes the race 14 meter ahead of Aman. So that means when he has reached, so how it could be ahead of Aman when Aman is 14 meter behind than Anthony, and Anthony's position is the finish line. So this is the first case. This is case 1 when we'll compare Anthony and Aman. In the second case, Akbar finishes 20 meter ahead. Now Akbar is finishing. Now according to Akbar's finish, when Akbar in the finish line, what is the relative position of the other one? 20 meter ahead of Anthony. That means that time Anthony is 20 meter behind. At the same time, Amar is 32 meter behind. So this distance when Akbar is in the finish line, this is 32. Understood? So there may be so many ways of thinking. Now we need speed. So that means if we think that X meter being covered in first case by Anthony, and accordingly I will take the speed of Anthony's A, all are A, no? So there is no distinguish. Rather I will say this is Anthony's speed is A, Akbar's or rather Akbar is the fastest one. I will say this is A, this is B, and your what is the Amar? Akbar here. Amar's speed is C. Amar. He is in here is Amar. So I will take his speed is C. So this will be distinguished. So first case when Anthony at finish line, so an X distance been covered by with the speed of B, the time taken in that same time, he is covering less than 14, so X minus 14 by who is he? He is Aman, isn't it? Anthony competes when the Amar. So Amar speed is we have taken is c. So this is one equation. In second case, Akbar in the finish line. So Akbar is covering x distance with the speed of a, where Anthony is a distance x minus 20 with the same in the same time with his speed. That means Anthony's speed we have taken b, and at the same time he is at 32 upon c. So this could be one answer. Okay, and one more thing we can calculate. This is the one way of, so there how many variables x is given, so x is known, so only b, a, c are unknown. So there if I say take that in between this we can solve this a, there is one equation, 2, 3, there are 3 equation, or you can consider this also one equation, the 4 equation. So you can calculate x, b, a, c, all can, because there are 4 variables, x is one variable, a, b, c are 3 variables, 4 variables. So there this equalizing you get 1, equalizing this you will get 2 equation, equalizing this will get 3 equation, and equalizing this also you will get 4 equation. There are 4 equation, 4 variable. I am not going to solve it, I am leaving it with you because I don't want to waste time. This is one process, or other process this can be thought like that. Just follow me. This is the first process by which you can solve all x, a, b, c. Okay, this is one process. Second process, you think in the different way. This is your how much, 32. Now see, in first location, first position, when Anthony reaches x distance, he is reaching 14 less. Now if I think this is the first condition when they are all racing together, that means they are into some race, that means they have started at same time. After starting same time, and being Akbar is the highest speed, he is reaching at the finish line. And the same time, they this is Anthony's position, this is Amar's position. Okay, then after this position will reach, because after Akbar reaches, Anthony will reach. So that's why he is the slowest one. So I mean to say, Akbar is covering 20 meters distance in at his own speed. In that time, Amar is covering 32 minus 14. I mean to say, Akbar is covering 20 meter in the same time. In the same time, so that means 20 meter by t time. How much is covering? This will be the speed of Anthony. Anthony is covering from this position, means 20 meter behind the Akbar from the finish line. Then after the position is, he is reaching the finish line. So 20 meter is covering, then only he can able to reach finish line. By that time, Amar is covering from 32 meter from the finish line, he is covering up to the 14 meter behind the finish line. So how much? 32 minus 14, that much is covering the same time, isn't it? 32 minus 14, this will be the time. So this will be the time, and if I say this is how much, this is with the time t they are covering. So the relative speed you can say, if I take the, because ultimately if I equalize with the t, it won't get any value. Rather, if I say this time and this time, if I equalize with the respect to the ratios, other than equalizing this you will won't get, because both that case this is t is the time, distance upon time is the speed, distance upon the, what is the speed ratio for them? This is the 20 is to, that is the 18, this will be the ratio. Then after it is the 10 is to 9 ratio. Okay, 10 is to 9 ratio will be the ratio between the Anthony is to Amar. This is the speed ratio. So I can also can represent Amar speed with respect to the Anthony speed. So Amar speed will be the 9/10th. Amar speed will be the 9/10th of the Anthony speed. That way you can represent. And because x is unknown for me, so x I cannot able to calculate, so I can represent it the answer in the ratio of this only. Okay, so what is the Amar speed? That speed will be the 9/10th of the Amar speed will be the 9/10th of the Anthony speed. That way you can represent the case. Okay. Yes. If I going to solve the first equation that I have given, that means x by the speed of the Akbar is a, the time taken by Akbar is to cover x distance is x by a. At the same time, he is covering x minus 20 by his speed b, Anthony, and x minus 32 by c by him. So this will be the one equation, where if I equalize this, so I will get x minus 20 upon x is equal to b by a with the ratio. So this will be the one equation. If we equalize this one, so x minus 32 by x is equal to c by a. This will be another equation. And from the first case, when this is x by the speed of Anthony is b is equal to x minus 14 by c, isn't it? That will be the, so there x minus 14 by x is equal to c by b. This will be the another equation. So c by b here also I will get by doing this c by b I am getting now. So if I equalize this, so I will get the similar equation by equalize this one. So x minus 32 by x minus 20, this will be c by b. So this is equal to x minus 14 by x. So now if we equalize this also, this will be the x minus by x, no? So this will be, if I multiply it, x square minus 32x is equal to x square minus 14x minus 20x minus 34x, and this multiplied together, 14 to the 28, 0. So x square 32, that means 32x is equal to 280. So x is equal to 140. So I am getting 140. So if I get 140, then x is equal to 140 we calculated. So I want to get Amar speed. So initially x by Anthony b is equal to x minus 14 by c. X is equal to 140. So 140 by b is equal to 140 minus 14 is equal to how much? 126 by c. So this is the first equation. Second, x minus x by a is equal to x minus 20 by b, x minus 32 by c. So x by a is equal to 140 by a. So 140 by a here is equal to 140 minus 120 by b, that is equal to 140, 108 by c. Okay, now individual can calculate b and c. Now we can compare this, means definite value will get b is equal to how much, and now I am to get c now. So c is equal to 126 by 140 by into b. Now if I equalize this, so this will be c is equal to again. Now from here also you will not definitely get any value of a, b, c, rather you will get the comparison means if we compare any of this with comparison to other, this is 120, no? So B by C if I do, so that is equal to 108 upon 120. Okay, so this is 108 means how much? 42743039310. Now see, C is equal to 9 by 10 of C. So B, sorry. So 9 the 10th of B means B is equal to Anthony speed we have taken. So here the advantage is that if in case option being given that what is Amar speed with respect to the Akbar speed, Anthony speed, then this will be the answer. Now if it has to be calculated or compared with respect to the Akbar speed, then also you can get it from here. But ultimately you will not get a definite value of ABC, rather you will get a comparison value. So this the first equation, this will be elaborate one. The second equation is a direct answer where you get the Amar speed with respect to the Anthony speed. Okay, so the both process is correct, but ultimately answer would be 9/10 of the Anthony speed. Okay, so now I'll move on to the problem number 41. Problem number 41. What it say? The long question. Let me write it down. Tom, Jerry, and Bill. Tom, Jerry, and Bill start from a point A at the same time. Start from a point A at the same time in their cars to go to B. In their cars to go to B. Tom reaches point B first. Tom reaches point B first and turns back and meet Jerry at a distance of 9 miles. Jerry at a distance of 9 miles from point B. When Jerry reaches B, when Jerry reaches B, he too turns back and meets. He too turns back and meets Bill at a point distance of 7 miles from B. If 3 times the speed with which Tom drives the car is equal to the 5 times Bill speed what could be the distance between A to B? What would be the distance between A to B? Okay. So Tom, Jerry, Bill starts from a point. Let's say this is A to B. They are reaching at the same time in their cars to go to B. Tom reaches point B first. Tom, three characters are there: Tom, Jerry, and Bill. So I assume their speed is accordingly with their initial of the name. So Tom reaches first, then coming back from B, turns back and meet Jerry at a distance of 9. So let's say this is 9. So when Tom coming back, Tom last position is this and Jerry's last position is also this. They are meeting at 9 miles from the B. Okay. When Jerry reaches B, then after Jerry is slower than Tom, definitely. When Jerry reaches B, okay, is to turn back and meet Bill at distance 7. So there are some other point where when coming back Jerry meet with meet with Bill. So Bill is slower. So for first case, Jerry on the forward journey is a reverse journey. In the second case, Bill in the forward journey and Jerry is the reverse journey. So these are the two conditions and of the race. So another condition is the Tom car. But if 3 times the speed with which Tom drives equal to the 5 times of the Bill speed. So that is also. So we are assuming the speed is that. So that this is fixed distance. Distance is not said. Let A be D. A B be D. I am assuming this is D. So D distance is covered by D plus 9 distance covered by Tom. D plus 9 distance covered by Tom with a speed of T. This is the time taken. In that time, what Jerry will cover T D minus 9 because I am assuming the total distance A to B is D. So this is Tom and this is Jerry. So first equation is over. This is first equation. Second equation similarly, when the second part of that, when Jerry is coming back, Bill is going forward. So in that case, similarly, what Jerry has covered D plus 7 and what is the speed for Jerry? J, and in that same time D minus 7 who is covering? Bill with his speed B. This is the second equation. Okay. So there are how many variables? 1, 2, 3 and 4. So this is one equation, this is two equation, and the third equation is what? 3 times the speed of the Tom. So third equation, 3 times of the speed of Tom is T, is 5 times the Bill speed, 5 of Bill. So what could be the distance between A to B? So what could be the distance? So there you can see D 1 and 3 equation, but equation I am getting 1, 2 and 3. There is no other equation can be achieved. So either I can represent their speed in terms of D. Okay, so I will not get any definite. So let me check if it is possible to have, because there are 3 equations I am not getting to find. The first is Tom Jerry starts the point B, same time the cars A to B, Tom reaches the point B first and turns back and meet Jerry at the distance of 9 miles. from the B. When Jerry reaches B, he to turn back and will at 7 miles per hour if 3 and there is no equal to 5 to the Bill's speed is what is the distance. So there could be some you can say trial and error method after solving. So let me check this. So this is T is equal to 5 by 3B. This is the first one. You can use it where T and B can be correlated. So to correlate that, I have to eliminate J from there. So what is J from here? From the first equation, J is D minus 9 by D plus 9 into T, and that is equal to J here is equal to D plus 7 by D minus 7 into B. So this will be, because this there I am getting D T and there also I am getting J. Sorry, I'm representing J in terms of B, I am representing J in terms of T. So those are equal. So and this is one another equation. Now obsolete these two equation, I need to have some space. So what I equalize? This equalize this. Okay, so ultimately J is not there in the picture. I am getting this one. So fine. Now again T is equal to 5 by 3. So I can put from there D minus 9 by D plus 9 into T is equal to your 5 by 3 into B is equal to D plus 7 by D minus 7 into B. Now see, B cannot be 0. So B can be cancelled out, not equal to 0, because all are having some speed, otherwise they will not move. They cannot be 0, they can have some value, so I can eliminate. Now see, all equation is in the term of D. So there is only one variable left. So D can easily be calculated from here, and there is your answer. What would be the distance between A to B? So D is the answer. So you can solve it for yourself. I am not going to solve it. Okay. Now I will move to the next problem, that is number 42. Number 42. Number 42. Okay, fine. What is it? Okay. This basically has it's a logical, so I will not going to solve it because there is no mathematics involved in that. So I will not solve. I will move to the next problem. Okay, what is it? Okay, this is having mathematics in that. When Saurav increases his speed from 20 kilometer per hour to 25 kilometer per hour, he takes 1 hour less than usual time to cover a certain distance. What is the distance usually covered by him? Covered by him. Okay, so this seems to be very easy problem. This kind of problem, there is no much you can say thought is involved. When Saurabh increases his speed, so he increases means there is some speed earlier, he is increasing from that 20 kilometer to 25 kilometer. Two speed is given, S1 is 20, S2 is 25. So whatever the information given, just write it down so that it will give you clarity. He takes 1 hour less, so that means if it is T is equal T1 is equal to T, in T2 he will take 1 hour less. Definitely this will be the case. To cover a certain distance, so both the case distance D1 is equal to D, I can take D2 is equal to also D, I am keeping the same distance. What is the distance usually covered? So from this equation nothing is left. What is that? Distance is equal to S1 into T1, so means 20 into T is equal to 25 into T minus 1. From there you can easily calculate what? T is known. If T is known, anything you put there means 20 into T, that is equal to D. So D also known. So you can solve it for yourself. This is one case when we are taking 2. So other case, if it is so, the distance is same. So that means you can take, otherwise what you need to do? D distance upon time. Initial speed is less, so time taken is more, minus D upon 25 speed, that is equal to 1. So from there also you can solve the equation. So D divided by 20 means it is the time taken initially. When he has increased the speed, time must be taken less, so the difference is 1 because 1 hour less. So this also can be solved in this method. Or else what I can do, he has increased speed 25, so distance upon the time taken, let be the T initial case, this is the speed initially, must be less, so D upon time 1 hour less, what is the speed, minus distance, this is method, you can say method 2. Initially I have shown method 1, this is method 3. Any of this you can use. So distance upon time, because distance is same, time is 1 hour less, so speed will be high. Distance upon time, speed will be less. What is the difference? 5, because 25 to 25 is equal to 5. So this also you can solve. Here there is 2 variable, whereas this is one variable, and this can be solved. This is one equation, you need 2 equations at least to solve it. So you can get D and T relation from there, and this will be very, means this is method 3, although this is very much, means this is lengthy than the other one. This is straightforward, where D will get immediately. This will take you, you need another equation, so that there is 2 variable. Another equation anyhow you can correlate. So D upon T, for second case this is 20, so this could be another equation, or else D upon T minus 1 also is 25, is also another equation. And with the help of this, so this is the most easiest one out of this 3 method, where you can get D directly. D upon speed, time, D upon T speed, and that is divisible to 1. Okay, so I'll move on to, I am not going to solve these equations. You try yourself, it will be very easy for you to solve. You just understand the method that I am using. Okay, so thank you for now. I'll move on to the problem number 43 in the next video. Thank you.